Hello everyone, welcome back to online class on physics, and today I am going to discuss a very important topic of optics, that is image formation by a concave and convex lenses and thin lens equation for convex lens. So in my previous lecture I have already discussed lens, spherical lens and types of spherical lens, that is convex and concave lens, and some important terms related to lens, that is optical center, first principal focus, second principal focus, focal length, focal plane, and we have also derived a very important relation, that is the lens maker formula for both biconvex and biconcave lens. So here I am going to discuss the image formation by lens and thin lens equation. So let's start the class. First, we'll consider the convex lens. So same as spherical mirror, the position of object basically decides the position of image. And for convex lens, we can get real as well as virtual image. So see what happened here. First, we can see if the object is placed at infinity. If your object is placed at infinity, then you will get the image at focus. If your object placed at infinity, then you will get the image at focus. Now, what is the nature? The nature of the image is real. It is a real image, is not it? It is a real image. And what is the size? The size of the image is highly diminished. So, in first case, when an object is placed at infinity, a real image is formed at focus, and the size of the image is much smaller as compared to that of object. Okay. Simply remember, if your object is at infinity, you will get image at focus. Okay. Now second case. Now for second case, if your object is beyond C, that is behind the center of curvature. Okay. Then in this case, you will get the image between focus and center of curvature on the other side of the lens. Okay. It is in front of lens, then you will get image behind the lens. Okay. So in this case, you can see if your object is beyond C, then you will get the image between focus, second principal focus, and center of curvature. And what is the size? The size of the image is smaller as compared to object. And what is the nature? Nature is real and inverted. Okay. Now see the third case. You can see the third case here. When your object is placed at center of curvature. When your object is placed at one center of curvature, that is C1, then you will get the image at other center of curvature, that is C2. What is the nature? Real and inverted. What is the size? Size is same as that of object. Okay. Now, next case. Now you can see, now your object is between C1 and F1, that is center of curvature and first principal focus. Okay. Now your object is placed between C1 and F1. In this case, you will get a larger image, that is real and inverted image, and larger image between behind C, behind C2, that is center of curvature. So in this case, your size of the image is larger as compared to that of the object. In previous case, that is from A to C case, you see that in all cases you will get a real and inverted image, but the size of the image is smaller. And when your object is placed at center of curvature, you will get a image at another center of curvature, and in this case the size of the image is same. Now when your object is between C1 and F1, that is center of curvature and first principal focus, then in this case you will get an image behind other center of curvature, and now your image is larger. Now next case, when your object is placed at focus. When your object is placed at focus, that is first principal focus, then you will get the image at infinity. And what is the size of the image? Of course, the size of the image is larger. Okay, nature is real and inverted. So you can see, तुम लोग यहाँ पे देख सकते हो, ऑब्जेक्ट जितना ऑप्टिकल सेंटर का पास जा रही है, इमेज उतना ही ऑप्टिकल सेंटर से दूर जा रही है. ठीक है, तुम ऑप्टिकल सेंटर का लेफ्ट साइड में ऑब्जेक्ट सिचुएटेड है, ऑब्जेक्ट जितना ऑप्टिकल सेंटर की तरफ जा रही है उतना ही तुम्हारा इमेज ऑप्टिकल सेंटर से दूर भाग रही है. एंड साइज ऑफ द इमेज कैसे चेंज हो रही है? जो फोकस पे था, जब तुम्हारा ऑब्जेक्ट इंफिनिटी पे था, तब जाके तुमको इमेज मिला है फोकस पे, दैट इज हाईली डिमिनिश्ड. नाउ जब तुम्हारा ऑब्जेक्ट बियॉन्ड सी, मतलब सी का बाहर था, तब जाके तुमको इमेज कहाँ पे मिला? अदर साइड पे, बिटवीन एफ एंड ट्वेल्व. ठीक है, जब तुम्हारा ऑब्जेक्ट सेंटर ऑफ कर्वेचर पे, एक सेंटर ऑफ कर्वेचर पे आ गया, हम लोगों को पता है lens has two surface, so we have two center of curvature, two radius of curvature. Okay, so अगर तुम्हारा ऑब्जेक्ट एक सेंटर ऑफ कर्वेचर पे आ गया तो तुम्हारा इमेज क्या होगा? तुम्हारा इमेज फॉर्म होगा दूसरे सेंटर ऑफ कर्वेचर, and in this case you will get it real inverted and size of the image will be same as that of object. Okay, now जब तुम ऑब्जेक्ट को लेके फोकस पे आओगे, दैट इज यहाँ पे तुम्हारा ऑब्जेक्ट किस तरफ आ रही है? ऑप्टिकल सेंटर की तरफ, तो फोकस में आ गया. जब तुम्हारा फोकस में आ गया ऑब्जेक्ट, तब जाके तुमको क्या मिलेगा? रियल एंड इन्वर्टेड इमेज. बट इन दिस केस इट विल बी एट इंफिनिटी एंड लार्जर इन साइज. ओके, now last case. Now your ऑब्जेक्ट इज प्लेस्ड बिटवीन फोकस एंड ऑप्टिकल सेंटर. मतलब तुम अब ऑब्जेक्ट को लेके और भी नजदीक सेंटर ऑफ दैट इज ऑप्टिकल सेंटर का और भी नजदीक आ चुके हो. सो हियर इफ योर ऑब्जेक्ट इज प्लेस्ड बिटवीन सेंटर ऑफ ऑप्टिकल सेंटर एंड प्रिंसिपल फोकस, in this case you will get a virtual image and large, enlarged and virtual and erect image. So it is the only case where you can get a virtual image with convex lens. So this example is very important. Some question may come. Okay, about this topic, some question may come. That is when you will get a virtual image with convex lens. So your answer will be when the object is placed between principal focus and optical center, a virtual image is formed and size of the image is larger as compared to that object. Here virtual and erect image. So this case is very important. Okay, because except this case, in all other case you will get a real and inverted image. But with this case, only for this case, you will get a virtual and erect image with convex lens. Now we'll discuss about concave lens. What is concave lens? We know that concave lens means the middle portion is thin and the edges are thick. Okay. Now for concave lens, we always get a virtual and diminished image. What about the position of the object? That is irrespective of the position of the object, in all cases we will get a virtual and diminished image. So here two cases we will discuss. First of all, when object is placed at infinity. When object is placed at infinity, you will get the image at focus. And the nature of the image is virtual and size is diminished. Okay. Now another case. In any other position, at any other position of the object, you will get a image in front of the object, and nature of the image is virtual and direct, and it is smaller in size. Okay, so these are the here we have discussed how the position of the object dominate the position of image. Okay, now see, we can summarize this in a table. Our discussion we can summarize in a table, that is for concave, first concave lens. For concave lens, the object location, when object location is infinity, then image will be formed as second principal focus, and image naturally is partial, erect, and highly diminished. And beyond infinity and zero, that is beyond optical center and infinity, at any position of the object, you will get a image between principal focus, that is first principal focus, and optical center, and the image naturally is virtual and erect. It is highly diminished. Okay, and for convex lens, only for this position, that is when object is placed between principal focus and optical center, you will get a virtual and erect image. That for all other cases, you will get real and inverted image. Okay. Now we will discuss about thin lens formula. Now what is the thin lens formula or thin lens equation? Sometimes it is called lens formula. So see, what is this? It is a mathematical relation between object distance, image distance, and focal length of a spherical lens. That is 1 by f equal to 1 by p minus 1 by u. Okay, and this relation is valid for both convex and concave lens and both real and virtual image. Now, we know all, we have already discussed the new Cartesian sign convention. Okay, and some assumption here. In order to derive the thin lens formula, we'll take some assumption. Okay, so first assumption is the lens should be a thin lens. Okay, and aperture of the lens should be small. And third one, the incident and refracted rays make small angles with the principal axis. That means all rays are paraxial. Okay, and last one is the object is a small object, that is point objects based on the principal axis. These are some assumption. We have already discussed this assumption when we have derived the refraction formula for spherical surfaces. That is, the aperture small, the all rays are paraxial, and the object is point object. Here only another assumption we are going to use, that is the lens used is thin. Okay, मतलब है हम लोगों को कुछ assumption लेना है. फर्स्ट है लेंस जो यूज करेंगे उसको थिन लेंस लेना है, दैट इज दो सरफेस का बीच का जो डिस्टेंस है वो स्मॉल होना चाहिए. सेकंड, एपर्चर स्मॉल होना चाहिए. ऑब्जेक्ट शुड बी पॉइंट ऑब्जेक्ट होना चाहिए, एंड रेज शुड बी पैराक्सियल, दैट इज द एंगल created by the incident and refracted rays with the principal axis should be small. Okay. Now, lens formula, we'll derive the lens formula for convex lens. So, there are two cases. First case is when a convex lens form a real image. We know that a convex lens, we can get both real and virtual image. Okay. The first case when convex lens form a real image. So see here. Here, an object AB is placed perpendicular to the principal axis of a thin convex lens. Okay. Now AB is placed beyond C, that is beyond center of curvature. Now this is the convex lens, thin convex lens, and O is the optical center. What is F? F is the principal focus, and the small f means focal length. Okay. Now, so for that position of object, you will get a real inverted image A dash B dash. That is AB is your object and A dash B dash is your image here. Okay. So you can see AB object and A dash B dash is your image. Now what is the image distance? He is your image distance, U is your object distance, and F is the focal length. Now start. Now you can see from these two triangle ABO and A dash B dash. This two triangle, in this two triangle AOB and A dash OB dash, angle is vertically opposite angle and equal angle. Again ABO and B dash ABO and A dash B dash O. This angle is 90 degree. So these two triangle are similar triangle. Is not it? ABO triangle and A dash B dash O triangle is similar triangle. If these two triangle are similar, so we can say that the ratio of two sides will be similar. That means here we can write A dash B dash by AB. See here, A dash B dash by AB equal to OB dash by OB. Similarly here, similarly you can see that A dash B dash F and MOF and MOF are similar. So if these two triangles are similar, because here this angle is vertically opposite angle, so it is equal, and this angle is 90 degrees. So these are also equal. So these two triangles are similar triangle. If these are two similar triangle, then you can take the ratio of sides, that is A dash B dash by A dash B dash by CO. Okay, A dash B dash by CO or OC equal to F B dash by 1. Now what is OC? See here, what is OC here? OC is nothing but the AB. So OC can be replaced by OB, AB. So OC can be replaced by AB. So you can get second equation like this. Now from first and second equation, left hand side is same. So we can equate OB dash by OB equal to FB dash by 1. Now what is FB dash? See here, what is FB dash here? FB dash means OB dash minus OF. So here I am writing this OB dash minus OF. So what is OB dash? OB dash is nothing but the image distance. What is OF? OF is nothing but the focal length. And what is OB? OB is nothing but the object distance. Now we'll use the sign convention. See here, U is in the left side, so it will be negative, and F and P will be positive. So here we can put the value here, and after that we'll get like this, and after that we'll simplify it. Nothing but we will simplify it like this. And our last step is we can divide this equation by UBF, and after dividing we'll get our required Lenz's formula or Lenz's formula. Okay, so it is the first case when the object is image is real. Okay, it is the first case where convex lens forms a real image. Now we will discuss about the second derivation, that is when it forms a virtual image. So it is the ray diagram here. First do yourself. If there is any problem, then I will do for you. Okay. So student, let's end the class. In our next class, we will discuss about Hinden's formula for concave lens. And if you have any problem regarding this, we will discuss it. Bye.